So now I'll introduce the concept of half-life. Okay, so a half-life is the time it takes, well, you've got a radioactive material here with the radioactive or unstable nuclei decaying with time and changing into stable nuclei. The time taken for the amount of radioactivity or the number of radioactive atoms to decrease to 1/2 is called the half-life. This is just schematically showing you these black dots of the radioactive atoms. You can think of it as the amount of radioactivity, and it decreases with time like that. You can have all sorts of half-lives. Uranium 238 has a half-life of 4.6 billion years. Technetium 99M has a half-life of 6 hours. Technetium 99M is the thing that's used in bone scans in nuclear medicine departments. Background radiation. People are constantly exposed to background levels of radiation, or background radiation, radioactive materials in the Earth's crust, cosmic rays, radioactive material in the air, and so forth. Now, there are two things I'd like to distinguish between irradiation and contamination. If I take this source here, I'm exposed to the radiation from that source, and I will receive a certain dose of radiation. However, when I remove myself from that source, I've just received a dose of radiation. I haven't become contaminated or radioactive. External radiation doesn't make a person contaminated or radioactive. If I take this radioactive material and grind it up into a powder, and I can inhale it, ingest it, or get it on my skin, where you've got radioactive material on you or inside you continuing to emit radiation. So that's contamination. So irradiation versus contamination. How do I measure it? So in Australia, obviously, we use the system, the international system of units. What do we measure? I'll just go through all of this, actually. So you can measure either the number of counts you get off this source, the activity of the source, so you can have a very strong source or a very weak source like this. The other thing you're interested in is if I've been exposed to this radiation from that source, what dose do I measure? What dose have I received? And that's exposure or dose. Later on, we'll be mucking around, or you'll be mucking around with a cipher contamination monitor, which you have over there. That measures in counts per second, although it can be set up to measure in microsieverts per hour. We'll go into that later. You've also got a dose rate meter, which will measure dose. What's the relationship between activity and counts per second? Activity is the, if you like, the number of, let's say, gamma rays that are coming off this source per unit time, and that goes out in 360 degrees. So you've got a radioactive source here emitting radiation, 360 degrees. The activity of the source is basically the amount of radiation emitted per second. Now, with that cipher contamination monitor, you put your probe here. You'll see the probe later on. That's the active area of the probe here. So, of this area around here, for starters, you are only intercepting this area with the detector. On top of that, well, obviously, the further away you are, the less area of that circle, or the less fraction of that circle you're going to intercept. So the reading on this depends on a number of factors. How far away you are from the source, it depends on the area of this detector, and it depends on the efficiency of this detector. What does that mean? Let's say I have two gamma rays coming in here. One might pass straight through without being detected, and one will be detected by the detector. So you've got a 50% efficiency there. What am I trying to say in all that? counts per second is related to activity, but it's not equal to the activity of the source. It can give you a measure of the activity of the source, though, and it measures in counts per second. And we'll see a lot more of that when you muck around with the detectors and some sources later on. Okay, so radiation activity is measured in a unit called becquerel. 1 becquerel is just, if you like, 1 gamma ray per second. And that's how we measure the radioactivity of the source. But 1 becquerel is a very small unit, just like a metre is not very particularly convenient if you're measuring the distance from here to the moon or something like that. So we'll tend to see things like kilobecquerel, megabecquerel, or gigabecquerel. So a kilobecquerel is 1,000 becquerels, a megabecquerel is 1,000,000 becquerels, and so forth. And that's what you're likely to see on manifests and so forth. The detector, as I mentioned before, you'll be, if you're using the cipher, you'll be looking at counts per second, which is proportional to the becquerels, but is not a direct measure of the becquerels. So that there is telling you how hot the source is, how much radioactivity is there. Then you're interested in how much or what radiation dose you've absorbed, and then we have to use a unit called a sievert. And that tells you what biological risk or effect you can expect. As you'll see with the detectors you'll be using later, you can either use accumulated dose or dose rate. So, and I think I've got a slide about this later. If you measure a dose rate of 100 microsieverts per hour, and you're in that environment for 2 hours, you'll get 200 microsieverts accumulated dose. And the dose in sieverts per hour, or microsieverts per hour, or millisieverts per hour is what you're going to see on transport placards. In fact, this thing here is a nuclear density moisture gauge. We'll be mucking around with that later on, taking some measurements around it. This is a real source that you're likely to see out there on the roads, and it is very typical of what you can, what you'll be responding to. And you'll see later on what sort of dose rates we're measuring from that and how hazardous that in fact is. But you can see here, this is a transport label, and that will have details like, what is contained in there and what is the dose rate and so forth. But we'll muck around with that later. A sievert is a particularly big unit of radiation dose, and so we tend to use things like microsieverts, or microsieverts per hour, and millisieverts or millisieverts per hour. The monitors you can use to measure, well, you might be able to see there the displays in counts per second, which is a measure of the radiation activity in becquerels. That's the cipher. Now it's going to be in the kits that the techs are going to carry around with them. And you've got these things here which measure radiation dose in sieverts. So you've got an order mess. You may be able to see there, probably not, or possibly not, that it's reading in microsieverts per hour. That's a handheld monitor that you can use to measure dose rate, and it's attached to, in this case over here, an extendable probe, which we'll be using to measure the dose rate with the extendable probe from these things here. You've also got a number of radoses, which are personal dosimeters, which you can attach to your belt or up here. And Chris will be handing out some of those to keep an eye on what dose you receive from this thing here. And if you get anything above 0, I'll be very surprised. So, as I mentioned before, a becquerel is a very small unit of radioactivity, so we tend to use things like kilobecquerel, megabecquerel, gigabecquerel, and terabecquerel. So natural background,